Hey everyone, so I'm going to do a quick walkthrough of problems 1 through 4 on the little review handout. And in a separate video, I will do some of the other problems, whatever it is, 5 through whatever. So here I have questions 1 through 4. And these are all from section 3.9, which is on local linearity, um, linear approximation, differentials. So here we go. I'm just going to go through the problems and explain the solution. You should definitely try all of these before you watch the video. Okay, so find the equation of the tangent to the curve y equals x sine of x at the point pi over 2 pi over 2. So I know sometimes it's like the trig functions get a little scary, but it's okay. Step by step. So here we already know our point. That's nice. The point is pi, by the way, I'm down here. I kind of separated, I spaced out the problem so I could write on it. So we have our point and we have our function. We're trying to find the equation of the tangent line. So we need to find the derivative, of course. So we're going to do y prime. Don't forget, this is x times sine of x. So we need to use the product rule. Okay, so I'm going to have my first times the derivative of the second. So the derivative of sine is cosine plus the second times the derivative of the first. And the derivative of x is just 1, and so this is what I'm left with for my y prime. And so now I need to know what is this derivative equal to when my x value is pi over 2. So we're going to substitute in the pi over 2. So I'm going to write it like this. Y prime of pi over 2 would be pi over 2 times cosine of pi over 2 plus sine of pi over 2. And then you got to think about your good friend, the unit circle. Pi over 2 is up here. And cosine is x, so the x value there is 0, so that means that this whole term is just 0, and then sine of pi over 2 is 1, and so this is 1, and so that's going to be the slope of the tangent line. And then we have our point already, pi over 2, so that is nice. And now we just need to write the equation. So we're going to have y minus pi over 2 is equal to the slope 1 times x minus pi over 2. And if I add pi over 2, I'm just going to end up with y equals x. So that is the equation tangent to that curve at that point. Okay, number 2. Use differentials to approximate f of 3.96 when f of 4 is negative 167 and f of x is that function there. So there are 2 problems on this review that say use differentials. I want you to know that you can still just use the tangent line. So in this example, I will use the tangent line, and in number 4, I will show you like the differential way to do it. But they're really doing the same thing, so you can use either method. Okay, so we know f of 4 is negative 167. We need to know f prime of 4, and to know, because that's the slope, and to know f prime of 4, we would need to differentiate f of x. So f prime of x is going to be negative 9x squared plus 8. Okay, that was nice. And then we're going to do f prime of 4, and hopefully, okay, I don't know. I'm relying on something I did a few days ago, so I don't know if this is right, but negative 136. And so that's going to be the slope. So you should use a calculator and check that. That's going to be the slope. And this is our point for negative 167. And so we're just going to go for it here with the tangent line. So we're going to have y minus negative 167, so plus, equals m, which is our negative 136, times x minus 4. And so that is the equation of the tangent line. And we're trying to approximate f of 3.96. And so you can just plug in the 3.96 where you see the x. And so now I end up with this. And then I'm getting negative 0.4, and then you would multiply those, and I think you get, here, let's just double check, times 0.4. Okay. Wait, 3.96, this is 0.04. Come on, Miss Lee. Okay, much better. So this is 5.44. So now I have y plus 167 equals positive 5.44. And then you would need to subtract the 167. And you get that. Okay, so f of 3.96 is approximately negative 161.56. I encourage you to plug it in here using a calculator to see if you get something similar. Okay, this next question isn't really like directly related to this. This is actually a review question. So this is something you should be able to do. It's not necessarily from 3.9. But the position of a particle along a straight line is given by that function s, where t is greater than or equal to 0. When is the acceleration positive and when is it negative? So this brings us back to something from, when was it? I think chapter 2. And so the position here is given by this function s. The velocity is the derivative of the position function. So v is the derivative of the position function. And then acceleration is the derivative of the velocity function, which is also known as the second derivative of the position function. So this is something you should know, and that will come up quite a bit. So here we're being asked about acceleration. So we need to find the second derivative of the position, and the position is what is given. So let's find the first derivative first. And then we're gonna differentiate again, and we get 12t squared minus 48t plus 36. And so this is the acceleration function. This is the acceleration function. And so when is it positive and when is it negative? Well, just make a sign pattern chart. We just need to know when this function, s double prime, is positive and when it's negative. And so, I guess before I need to find the critical number. So factor this, 12 t squared minus 4t plus 3. And that's going to be 12 t minus 3, t minus 1. So positive 1 and positive 3. And then be careful here, this actually won't continue on forever. It stops at 0 because we were given that t is greater than or equal to 0 because it's time and we're not going to go into negative time. And so then you test your intervals, and here we get s double prime is greater than 0. Here you should get less than 0, and here you should get greater than 0. And so when is the acceleration positive? It is positive on the intervals 0 to 1 and 3 to infinity, I guess. Yep, infinity. And then it is negative on the interval 1 to 3. All right, so that is that one. And then the last one, so use differentials to approximate the value of this. And so when you're given something like this, what you want to first do is identify what is the function. And so here the function is f of x equals like something to the fourth power. So x to the fourth power. And then we need to identify, it's pretty much like a whole number here. Like what would be the easiest number to do would be 7. So we're going to choose the nearest whole number. If it's a square root, you should choose the nearest whole number that you know the square root of. So here I'm going to choose my x is 7, and my delta x should be the difference between the number you pick here and then the number you're trying to find. And so the difference between 7 and 7.035 is 0.035. And we are going to now use differentials. So what does that mean? Well, in the notes, there was this formula. By the way, you could do this using the tangent line. You could write the equation of the tangent line to this function at the point 7, and you can use that. Okay, so you should try it that way too, maybe, if you're interested in comparing. But delta y is approximated by dy. So this is the differential. And dy is found by taking your derivative and multiplying by dx. And so this is what we're going to try to do right now. And so what is f prime of x? Well, the function f of x is x to the fourth, so this is going to be 4x cubed. And then dx is delta x. So this is dx. They're the same thing in these types of problems. They are the same thing. So this is 0.035. And so this is dy. And we need to know dy when, wait, what am I doing? Okay, we need to know it when x is 7. So we're going to plug in the 7 here and then see what you get, okay? I'm gonna move a little fast because I'm supposed to be in office hours right now. And then that's the approximated change in y. That is the approximated change in y. And so what you're going to do now is find your actual f of 7, right? Find f of 7 and then add the dy to it. And that will be approximately f of 7.035. Okay, because you're just saying like, okay, what is this y value? And then what is the approximate change in y? So whatever you get here, you add it. And then I think you should end up with 2,449.02. So that's how you do it the differential way. You can certainly do it the tangent line way. And I encourage you to try it that way as well. Okay, let me know if you have any questions.